Hello, my name is Nazeer from the Faculty of Civil Engineering Technology, and I will be demonstrating for you today the procedure of completing the squares. The procedure for completing the squares is written right here. You could read through that. I'll go through the process. Completing the squares is used to change a trinomial to a perfect square trinomial, which then could be factored as a binomial squared. Again, we are changing a regular trinomial to a perfect square trinomial, and then we are writing it as its factor as a binomial squared. We have a trinomial here. The first thing that we have to determine, is it a perfect square trinomial? The procedure for that is if the middle term is equal to the product of the root of the first and last term multiplied by 2, then it is a perfect square trinomial. Okay? Let's go and do that check. I'm going to take the root of the first term, which is r, the root of the last term, which is 2, and multiply them together. I'm going to carry the sign, so I'll get minus 2r times 2 minus 4r. That middle term is not minus 4r, therefore this is not a perfect square trinomial. Okay? We're going to use the procedure of completing the square to actually change it into a perfect square trinomial. The first thing that we have to do is get rid of this c term and replace it with the appropriate c term that will make the left hand side of this equation a perfect square trinomial. Let's go and look at that. To get rid of the c term, I'm going to take it to the other side. It becomes a plus, and as you can see, it's right there. It becomes plus 4. What am I going to replace the c term with to make this side a perfect square? I'm going to look at the coefficient of the b term, and I'm going to divide it by 2 and square it. And that makes this side a perfect square trinomial. What I do to one side of an equation, I have to do to the other side of the equation to keep it balanced. If you think of it as a scale, it has to be balanced. So I have to add this particular term to the right hand side also. Okay? If you look at the added term, if I were to square 10, it becomes 100. Square 2 in the denominator, it becomes 4. You simplify that, 100 divided by 4 will give you 25 right there. We have a perfect square trinomial on this side. We could reduce the right hand side or simplify it to become 29. So now we're able to write the left hand side right here as a binomial squared. The procedure for that, I'm going to take the root of the first term, the root of the last term, with the middle term sign in between them, in brackets, squared. And that will give me the factor of this perfect square trinomial. Okay? Root of the first term, root of the last term, carrying the middle sign, in brackets, squared, will give us that. Now, if you remember from special product, if we have a binomial squared and we want to expand it, there's two methods of doing that. You could do it by FOIL. The simpler way is to take the special product way, square the first term, put it in the first position, the product of the inside times 2. So the product of the inside here would be 5. R times 2 will give us 10r, and then square the last term of the binomial and put it as the last term of the trinomial, which is where we actually came from. R squared plus 10r plus 25. Okay, so we know this is the factor of that trinomial. This binomial squared is the factor of that trinomial. The 29 stays the 29, and in this case we are trying to isolate the variable which is the r by itself. To do that, we have to get rid of the square term. We have to get rid of the square term. To get rid of a square term, you take the root of it. You take the root of a square term, it just gives you the r plus 5 is, and then you have to do the same thing to the other side. It becomes the root of 29. Now, we have a plus or minus in front of the root of 29, and that is because there's two possibilities for the root of 29. When you take the root of something, there's two possibilities. If we were to take, say for instance, 4 and we square it, we'll get 16. And if we take minus 4 and square it also, we would get 16. So you could see that there's two possibilities. The plus possibility is called the principal root, and the minus possibility is considered to be the secondary root. The other reason for that is that when we have a quadratic form and we graph it, it is graphed to be a parabola. A parabola has two solutions. Okay, so that is where you get the rationale for the plus or minus. Okay, that's where you get it. We want to isolate the r by itself, so we have to take the plus 5 over to the right hand side and make it a minus 5, and that's what we have here. Now we have two answers here. R is equal to minus 5 plus the root of 29, and R is equal to minus 5 minus the root of 29. So those are the two solutions. Now what I've demonstrated here is just one way, one possibility of doing completing the square. Let's go and look at the other possibility. This is the second example that I'm going to do for you, and the difference between this trinomial here and the previous one is that this one has a coefficient other than 1 for the squared term. It has a coefficient other than 1. Before you could do completion of squares, you have to make that coefficient into 1. It always has to be 1. Okay? To do that, I'm going to divide every term in this equation by the coefficient of the x term. In this case that coefficient is 2, so I'm going to divide everything by 2. It becomes x squared by itself. There's an understood 1 in front here. Understood 1 in front there. If I divide 16 by 2, I get 8x. And 9/2 remains 9/2. We keep it as an exact number. Now we are in the form, the general form that we could do the procedure of completing the squares. We are in the general form. We have to get rid of the c term, replace it with the appropriate c term, and simplify. Okay? I have to take this 9/2 minus 9/2 over to the right hand side. It becomes plus 9/2. I'm going to replace that 9/2 with the appropriate c term, which is 1/2 of the coefficient of the b, 8 divided by 2 squared. What I do on the left hand side, I have to do on the right hand side. Okay? So now I have a perfect square trinomial on this side. I have a constant on the other side. Let's go and simplify this a bit. When I simplify this side here, we'll have 4 right in here. 4 squared is 16. So both of these become 16. And that's where we have the 16 here. Okay? We have a perfect square trinomial here. We could factor it as a binomial squared. Take the root of the first term, place it in the first position. The root of the last term, place it in the last position. Carry the middle sign, put it in brackets, and square it. To reduce or simplify the right hand side, I'm going to write this 16 as an equivalent fraction. It becomes 32 divided by 2, which is really 16. Once you have the same denominators, you add the numerator. So this 32 plus 9 will give you 41 divided by 2. So that's how you reduce that side. Fairly simple procedure. You have to have the same denominators, and you add the numerator, you keep the common denominators. Okay? To have the same denominators of 16, I have to multiply 16 by 2 divided by 2. 16 times 2 is 32 divided by 2. And then you add the numerator, which is 32 plus 9 is 41 divided by 2. I need to isolate the x by itself. I have to get rid of the square. I have to take the root of that square to get rid of it. Okay? When I do the root of the left hand side, I have to have the root of the right hand side, and we have to have the plus or minus because there's two possibilities here. Okay? When we look at this, this is a quadratic form, so it's going to graph to be a parabola. I'm going to get rid of the 4, the plus 4, take it on the other side, it becomes minus 4. and it'll become minus 4 plus the root of 41 over 2 and minus 4 minus the root of 41 divided by 2. These are the two solutions to this equation. And I hope that this demonstration helped you with completing the squares, and that is all I have for you right now. Hopefully you understand everything. Thank you. Bye-bye.